And there's a theory lesson on circles and their equations. So a definition of a circle is the set of all points which are a given distance from a given point. So I define where the point is, I define the distance away that all these points are, and if I have an infinite number of these points around here, all at the same distance, it'll form a circle, a prettier circle than that. What does the equation of a circle look like? Well, if it's centered at the origin, so center here, it's of the form x squared plus y squared equals r squared, where r squared is that distance from the circle. So what we're going to do is construct a table of values to plot a graph of this circle, which, looking at the formula, will be centered at the origin. And since 25 is my r squared value, that implies that my radius is going to be 5. So I'm hoping to get something like that around 5. Okay, but I won't just assume the formula works. I'll go ahead and substitute in some points. So they're strategically chosen points, but we'll still get an idea of what's happening. Just as I do whenever I'm plotting a set of points, I'll substitute in these values. So I'm going to sub in x equals minus 5 into the equation x squared plus y squared equals 25. So wherever I see x, I'll replace it with minus 5. And I'm trying to find out what the y value is. Minus 5 squared is 25. So I end up with y squared equals 0. Y equals plus or minus square root of 0. And y is plus or minus 0. So really just y equals 0. So I have a point already at minus 5, 0, which I can mark on my axes. Sounds pretty easy. Let's see what happens when I sub in x equals minus 3. See if the same thing happens. Minus 3 squared is 9. So y squared is 16. And I better do the plus or minus square root to get y equals plus or minus 4. So this probably isn't something you've seen before, but in my table of values, I've got plus or minus 4. So at minus 3, it can either be a positive 4 or at negative 4. So I want you to go ahead and substitute in these other 4 values and plot their points on that xy plane. Hopefully you did it yourself. Looking at some of these solutions, this one is a surd, so we just get a decimal approximation for it. And when we sub in x equals 6, we get no solution, because we get to this point where we're trying to find the square root of a negative number. Okay, but hopefully you've gone and done that yourself. Plotted all these points, we can now go ahead and connect them to draw the circle. So there's my circle, I've written the relation of it beside it, so we know what it is. Okay, and that was plotting. Okay, if I instead am asked to sketch the circle, I don't need to do up the table of points. I know that the circle formula works. I can just identify that this is x squared plus y squared equals r squared. So it'll be a circle with a center of 0, 0. Since r squared equals 16, the radius will equal 4. Now it should really be plus or minus 4, but we'll reject that negative one. So what that means is that from 0, 0, where the center is, I'll go 4 in the negative x direction, 4 in the positive y direction, 4 in the positive x direction, and 4 in the negative y direction, and from there join them together to make a circle. So again, to look at the difference, plotting is you're a robot, just put in some points. Sketching is use your knowledge to just show the interesting points. So I'll show the center and the 4 extreme points of the circle. Centered at the origin. So if I have a circle with a center, say HK, so say I mark this point HK, here it is, and it has a radius r, so again some radius around it, it'll be described by this equation. Okay, the only difference is this minus h and minus k factors in that the center has moved. So we'll have a go at plotting this equation, x minus 1 all squared plus y plus 2 all squared equals 25, this one. So from this I can see that the radius is probably going to be 25, correction 5, because r squared is 25. And my h value is 1, and my k value is minus 2. How do I get minus 2? Minus 2 gives me positive 2 in the equation here. Okay, you'll get used to this. So it seems like the center is going to be 1 minus 2, and the radius is going to be 5. So I'll substitute in a point. I'll sub in x equals minus 4 into the equation and see what happens. Actually, I'll sub in minus 3. You can do the other ones. Minus 3 is probably more interesting. So wherever I see x, I'm going to write minus 3. And minus 3 minus 1 is minus 4. Minus 4 squared is 16. You'll notice that I haven't expanded those brackets, even though it's quite tempting. You'll see why that is. Once I get to this stage, I can take the square root of both sides, plus or minus square root of both sides, and end up with y plus 2 equals plus or minus 3. And I can bring the plus 2 over, and this will give me my two solutions. So whenever I see a plus or minus, I need to consider both scenarios. So y is either plus 3 minus 2, or y is minus 3 minus 2. Okay, to cater for those two scenarios. So my y value is either 1 or minus 5. So 1 or minus 5 I'll put in here, and I'll plot where these 2 points are, and then from there I can do that for all of these other points. I want you to do these all manually, so press pause and sub in these values. You'll get a lot more out of it doing it yourself. So there's all the points, and I'll be able to join these together and make it into a circle. If we look at the 4 most extreme points and just draw straight lines around them, you'll see that there is my center, and the coordinates of my center are 1, minus 2, just as we predicted, and the radius 1, 2, 3, 4, yep, 5 units all the way. Okay, so these formulae do work. The other thing, just for interest's sake, is when you learnt quadratic equations, you would have been taught that you can either have 1, 2, or no solutions. Here's one solution, here's 2 solutions, here's no solutions. So all the way here you've been solving quadratic equations, and we've seen the 3 scenarios. This is plotting, being a robot putting all the points in. We also want to be able to sketch. So if I'm asked to sketch it, just show the interesting points, I'll write down my rule for a circle. So that should be r squared at the end. I know that r squared is 36, so my radius will be 6. I know my h value is 4, my k value is 3, which means my center is 4, 3. So I'm going to find where 4, 3 is, mark my center, and then I'll go 6 units in every direction. 1, 2, 3, 4, 5, 6. Do the same in all the other directions. And I can draw the circle around. It looks a lot better than mine, but I'll write the equation out of it just so that people believe that it's actually a circle. Remember, this is sketching. I've marked where the center is, and I marked the interesting points. In some problems that you'll be set, sometimes this value here might be something like 5. So r squared value is 5. Just take the square root of 5 and get some approximation for it. And so from that center, go out whatever root 5 is, like 2.3 or something, I don't know, in each direction and mark where that point is. So just in relation to circles, 2 other tasks that you should be able to do is write the equation. So if you're told the center of a circle is 1, 2 and its radius is 5, this is basically telling you that h and k, h equals 1, k equals 2, and the radius is 5. So you can substitute those values into this equation. I'd write x minus 1 squared plus y minus 2 squared equals 5 squared, and I'll just square that radius as 25. And in a similar way, his center is 5 minus 4 and radius is 7. Tells me h equals 5, k equals minus 4. Substitute it into my formula. X minus 5 all squared plus y minus, well, it's minus 4. So I've got to be careful here. The minus minus means plus. And I go to 49. Okay, the only other skill that you need to have is to be able to test points to see whether they're inside or outside the circle. The way this circle formula works is this part of the equation is essentially the distance squared from the center. If you remember your distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared to tell you the distance between 2 points. This is literally telling us the distance. If I put minus 5 there and plus 1 there, the distance from the point 5 minus 1. Okay, so the left-hand side is the distance from the center, and this 9 here is just the radius of the circle. Okay, again, squared. Test it is sub in a point. Okay, if the distance squared equals the radius squared, so left hand side equals right hand side, that means that it's on the line or on the circle. Okay, if the left hand side is greater than the right hand side, that means that the distance away from the point is bigger than the radius of the circle, so it means that it would be outside. And if it's less than the right hand side, means that the distance away from the center is smaller than the radius, so it means that it would be inside. So you can see how this works testing these 2 points. X equals 2, y equals 0. So I'll sub these points in. And see what the left hand side gives me. Okay, this doesn't look like it's going to be working out for me, so it's 10 equals 9. So I know that the left hand side is greater than the right hand side, which means that 2, 0 is outside the circle. You can do a similar thing with 8, 1. Turns out they were both outside the circle, which is a bit disappointing, but I think you understand how that decision rule would work. So from here, there's a few problems for you to have a go at. And if you get really stuck, there's some solutions to those problems.